Question 47. It's a difficult question, but we're able to use Desmos to help us figure this out. It says a scientist dropped an object from a height of 200 feet. She recorded the height of the object in half-second intervals. Here's her data. So based on a quadratic model, even told you it's quadratic, which when you drop something, it ends up picking up speed until it reaches its terminal velocity, but we don't really care about that. So we want to graph this. So it wants to know, hey, we gave you to 2.5 seconds. Where do we expect the answer to be when you're at 3 seconds? What's the height? Well, we know it's going to be under 100, which here are our options. So is it going to be 80 feet, 65? We want to figure this out. So we need to go and put all this data into a table. So we're going to go to Desmos, and we come to Desmos. Now, how do we add a table? Well, right here's a big plus, and you hit table, and then you enter all the data they had. Now, I already did it. Right here it is. I entered the data. So now I need it to give me an equation to model that data. So what do? Well, I have to use the quadratic. Now, if you remember on the quadratic, what we're going to enter, the quadratic is always like y equals something x squared plus something x plus something else, another third number. We use to represent those A, B, and C. So we got to put this equation in. But to tell it to look up at our data, we're going to put that little sub 1 on our x values and y values. Also, instead of an equal, we're going to put that little tilde. So let's go back and do that. So we're going to come here, we're going to type y, and then I need my little tilde. I need to put a sub 1 first, so I just type 1, and it knows to do that. Notice it says equal, 6-element list. It knows, hey, you want us to look at the data in the table. Now I'm just going to hit the shift and right beside my 1 key, and it puts the tilde in there, saying approximately. And we wanted to do A, and then we had x squared. We can hit the little squaring there. And I need to say, what did I need though? Oh, I needed it x sub 1. So I need to back up and say, hey, I meant to type a sub 1 there and then square it. Okay, we want to make sure we don't make that mistake. And then we're going to say plus. We're now going to say B. So I'm going to type B, and I want my X, but I need it sub what? Sub 1. So I just hit the 1, and then I say plus, and I type in a C value, C. Okay. Now, notice that what it has given us is it's given us this equation. We've typed it in. It gives us an R squared value of 0.99. It's like, hey, this is pretty accurate. It's actually hit our points too. If we look at our graph. Now, what it's done is there's our points. So you can see it's this parabola, and it's an upside down one. And that tells me my A value is going to be negative, which, yes, my A value is negative 6.423. And it says, hey, what's going to happen when X is 3? Well, you could write this equation out of y equals negative 16.4286 x squared plus the B value 1.07x, then plus the 199.643. Or if we just come in here, we're trying to go right here to 3. Right here we're almost at 3. Right at 3, what value do you see? 55. So at 3 seconds, that object we dropped is at 55 feet. So if we go back to our question, it's going to be, according to our model, it should be at a drop of 55 feet is where it should be. It's a pretty big drop. You could have gotten close to that answer if you had noticed this is going down 35, and then here was down 30, then 35. So you knew maybe 40, so around 60. So you knew these sort of were out. So you knew you were probably in that range. But again, we'd rather use pure math to figure it out and use what we did there with Desmos to get it. Very difficult problem, I get it, but you can do it if you just practice.